all those natural disasters we've been having recently. We'll be seeing more and more of them, and they'll get worse and worse. We're headed for unprecedented humanitarian disasters, unless we can cut our CO2 emissions almost entirely. We'll focus on the production of electricity, which accounts for about 50% of CO2 emissions. And in the production of electricity, we know the most likely candidates, solar and wind. But we also know their problems, variability and storage, and the fact that our network was not conceived for distributed generation of power. And no matter how successfully we pursue these renewables, we'll always be pushing the limits of variability, storage, and network capacity. But there is an incredibly good alternative. If we use only 1% of available resources, that gives us 500,000 times as much energy as all the fossil fuels there ever were combined. 500,000 times, using only 1%. This resource is called heavy water, and it's a small part of regular seawater, so it can be taken from the oceans. Heavy water can undergo a process called nuclear fusion, which is entirely different from nuclear fission, the standard nuclear process you would think of when you think of nuclear power. And one of the main differences is that nuclear fusion is entirely safe, and I'll come back to why later on. Now let's get back to that seawater. These are regular seawater molecules, and the important part here is the hydrogen atom. This is normal hydrogen. But some hydrogen atoms have an extra neutron in the nucleus. We call them deuterium. And then some other hydrogen atoms have yet another neutron. We call them tritium. Deuterium and tritium are the ones that fuse together. This reaction of deuterium and tritium is the most natural source of energy there is. It is the source of all our energy, because it is what makes the sun shine. And exactly there lies our challenge. This reaction only works in circumstances very close to those inside the sun. We can create those circumstances, but we cannot maintain them yet. As soon as some of this glowing hot plasma touches the walls or even gets close to the walls, the temperature drops too much and it's game over. And exactly that is why fusion is so safe. If anything goes wrong, it just stops. The opposite way around from nuclear fission. A reaction that will accelerate out of control unless it is actively stopped, actively slowed down. I'm sure you see the fundamental difference in safety. So we must keep the plasma from touching the walls. We use electromagnets to do this. This is just one of 13 total electromagnets. And that's what scientific research into nuclear fusion is about, plasma confinement. There are many phenomena that we're still working to understand. Sometimes they're helpful, such as the H mode or high confinement mode, where the plasma suddenly switches from a more turbulent state to a more organized one, and that helps confinement. But there are still some instabilities which of course we're working to avoid. Now you may say, okay, I heard this story 20-25 years ago if you're old enough, and you may even have heard the common one-liner that nuclear fusion is the energy of the future, and it always will be. But I want to show you just how much progress has been made. Since 2010, a French research group at the École Polytechnique has been producing better measurements of what happens inside the plasma using a novel technique called Doppler diffusion. This group is part of the ITER project, the International Thermonuclear Experimental Reactor, a big research facility which is being built up in the south of France. And this result and all the other scientific results that have come in recent years have allowed another partner nation in this project, China, to achieve a 50 million degree plasma and sustain it for a full 100 seconds. Now contrast with 1957, where even 300 microseconds was already enough to be worthy of a scientific publication. Think again for a moment about where all this leads. Cheap, abundant, safe energy. We could use some of it to capture back CO2 from the atmosphere. So much can be done differently and better. So think about this, and if you're in a position to support research on nuclear fusion, then please do. Give your little push to clean and abundant energy.